Okay, so welcome to the RoboRIO and Sensors workshop. I'm Tim, the electrical lead on 1678.
I'm Rachel, and I'm also on electrical on 1678.
So we're going to start with sensors. So a sensor is a device that detects or measures a physical property and records, indicates, or responds to it. So why do we use sensors? We can use them to feedback or position robot parts in your robot, like certain mechanisms on your robot. You can use them for motion control, use them on your drivetrain to find out how fast or where your robot moved, and to detect field elements inside or outside of the robot. So your robot can see the field elements during a match and find out if it intake the field element and has control over it. So this is our robot from this past season. We used many sensors on them. We had to have an elevator. We used sensors to find out where our elevator is positioned and if we intake one of the yellow cubes.
So choosing a sensor. When choosing a sensor, it can be hard to choose the right one. There's so many sensors out there that it's just really difficult to find one that works. Some things to consider are its purpose, what you're going to use it for, any electrical restrictions you might have, and price range. So depending on what your sensor is being used to detect, you may need it to meet certain requirements. It might need to be really accurate or precise. So some sensors, like encoders, have a maximum speed that they can measure. So make sure that you look up what the sensor you're considering can actually measure and make sure that that meets your requirements. Another thing is where the sensor is going to be powered from. Sensors take different voltage and current, so make sure that your robot is able to meet your sensor's needs. Different sensors output different signal types, which we will go over later.
And another thing about sensors is that different sensors have different indicator lights. So you could choose a sensor that has nice lights that you like, and it'll tell you if a signal is getting sent to your RoboRIO without having to trace all the wires and everything.
We're now going to go over some examples of sensors. A limit switch is a sensor that can sense field elements. It works when something presses a switch, it closes the circuit and sends a signal back to the RoboRIO or speed controller. It has a potential for mechanical failure, so you can also use the Hall effect, which is similar to a limit switch. It detects magnetic fields. And so how that works is if you have a magnet on a mechanism, then you can place the Hall effect in a certain location, and once that magnet passes that location, you know its position.
So another type of sensor is the encoder. The encoder detects rotational position and/or rate, and this is a type of optical shaft encoder where this shaft would rotate and you can put them on your mechanisms and drivetrains to detect how fast your robot's moving and how far it went. Another type of encoder is this kind, which is a mag encoder by CTR Electronics, and that's what our team started to use. And encoders are really important sensors because no matter what kind of new FRC game, you'll most likely always use encoders. And then another sensor that detects rotational position is the potentiometer. That's the one over there. And it's basically a variable resistor, which outputs an analog signal and can be used for degree of motion. And the mag encoder connects through a ribbon cable, and you can put it directly onto a Talon SRX speed controller.
A gyroscope is used to measure angular motion. This can be used to know where you are, which direction your robot is heading, and to keep it going in a certain direction. An accelerometer is used to measure acceleration. This is commonly used to measure robot tilt, in which case it's measuring acceleration due to gravity. There's a 3-axis accelerometer built into the RoboRIO, but it's not super accurate, so it's better to use an outside sensor. Proximity and beam break sensors are both used to measure or to get a sense of where an object is. So proximity sensors, there's many different types, including ultrasonic, infrared, and magnetic. And beam break sensors, they have an emitter and a receiver. And so when something crosses between them, you know that there's an object there.
So you can also use sensor boards on your first FRC robot. And an example would be the FRC gyro board and the Pigeon IMU. And they can be used to connect to your robot. They have many uses, such as the Pigeon has accelerometer and gyroscope. And that's what we started to use instead of the gyroscope on the Spartan expansion board. And the use of sensor boards can expand your robot's capability and create a competitively successful robot. And the Pigeon attaches directly to the Talon SRX data port, or you can wire it into the CAN loop with a wire soldered connection. And the Talon SRX data port is very useful for interfacing sensors, and you can connect analog sensors encoders such as the CTR Electronics mag encoder and limit switches. So there's a diagram of the pins on the data port. You can also put a Hall effect sensor by connecting it to the limit switch port and then powering it with a 5-volt power source. And it's a lot easier than routing wires to your RoboRIO. Can save space and make your wiring better.
So once you have selected a sensor, it's time to set it up. There's many things to consider when mounting your sensor. It needs to be in a location where it will not be hit by other field elements, other robots, or mechanisms on your own robot. It has to be securely attached. Otherwise, if it moves around, then measurements could be inaccurate and inconsistent. So while it needs to be protected and secure, it also needs to actually do its job. So make sure it's in a place where it can sense what it needs to sense. Another thing is noise. Noise is any sort of unwanted disturbance in an electrical signal. So this can come from motors. They have magnetic fields that can interfere with sensors, or from any wires carrying a bunch of current. So some ways to prevent this is moving it away from anything that could cause that, or also a Faraday cage, which is a metal enclosure that balances out the electrical signals from any other places. Interface types. There's different types of signal. DIO, which is digital input-output. It's simple and easy to use. It consists of either full voltage or no voltage, which is true or false. Analog contains more information, but it's more prone to being affected by electrical noise, so it's not as precise. Digital serial is a string of digital signals, and it can carry a lot of information, but it is complex to use.
So now we'll talk about the RoboRIO. So this is the RoboRIO, what it looks like. So the RoboRIO power, it takes an input range of 7 volts to 16 volts. And usually on a robot, it would get 12 volts because that's what the batteries are rated for. But when the voltage drops to 4.5 volts to 6.8 volts, the RoboRIO enters a brownout mode. And that's when certain features start to get disabled to save power. And here's the chart from the RoboRIO user manual that describes all the things that happen in the brownout mode. One example is when it goes from 6.3 volts to 6.8 volts, the voltage rails on the side of the RoboRIO get disabled. So if your robot starts to act differently or unexpectedly should always make sure that your battery is in good condition.
The RoboRIO has a bunch of status LEDs on the top right corner. And so they have the labels next to them. The one labeled power indicates whether it is getting the correct amount of power. The lights, this table shows the lights and the condition stating what the lights mean. The status indicates the status of the RoboRIO if it's in the middle of its self-power on test. The radio indicates whether it is connected, and the communications is communication status. The mode is what mode it's in, and the RSL is identical to the actual RSL, showing whether it is enabled. There's a user manual that has tables for each of these lights with a complete list like this one, so you can look that up if you need to know.
So CAN stands for the Controller Area Network, and that's a controller network that the RoboRIO supports. It's used for devices and sensors to communicate with each other. And the CAN controller has the devices that are daisy-chained together where they're one after the other. It includes the CPU, central processing unit, and that's what decides what the received messages mean and what to transmit. And then the CAN controller is part of the microcontroller that will wait and store a message until it's fully delivered and wait for the bus to be free to send signals. So the CAN is a good setup for sensors to communicate with each other. And the you can have a wiring setup where you put all your sensors and speed controllers in the CAN loop. So here are some speed controllers that are linked to each other through CAN wire. And then when you have a CAN setup, you have the devices all linked to each other neatly with one main wire. But without CAN, you can have lots of wires all coming to one center computer, which can get messy and inefficient. And in FRC electronics, there are three main components that are always required to be in the CAN loop, which are the PDP, PCM, and RoboRIO. And in the CAN loop, it requires 120 ohm terminating resistors on each end of the loop. So the PDP includes one, and when you have that on one end of the loop, you would need to have the terminating resistor jumper set to on, and then the RoboRIO includes one inside. So in the standard robot wiring, if you do not choose to put any other devices in your CAN loop, you would usually start with a RoboRIO and end with the PDP. And a useful component that can be used in a CAN wiring setup is the CANifier. So that's what that looks like. And it's a CAN control device that you can connect your sensors onto these GPIO pins. You connect digital sensors and it'll interface them into the CAN loop, and it gets rid of the need for wiring all of your sensors to the RoboRIO. It can also be used as a LED driver. You can connect your robot lights to it and program those. I2C is another protocol that the RoboRIO supports. It's used in many fields, except not as much in robotics, FRC robotics. 1678 does not use this. We use CAN for our sensors, but it supports LED drivers and digital sensors.
DIOS, as I already mentioned, stands for digital input output. It is an input or a control type used for sensors. It has three wires like this one here, used with ground, voltage, and signal. So when a sensor is using this, it can output either 3.3 or 5 volts or 0 volts depending on the, or 3.3 or 5 volts depending on the sensor, or 0 volts, read as a 1 or a 0. The RoboRIO the RoboRIO reads this as a 1 or 0, and sensors that use this only have 2 statuses, like the Hall effect, the proximity sensor, and the limit switch. PWM uses the same kind of wire. It stands for pulse width modulation, and it has cycles of full voltage and no voltage. So this is used to simulate an in-between voltage. If a sensor outputs full voltage half the time, then it's as if it were outputting half the voltage the whole time. So this can be used for motors. Running them at half speed, you would have half the time full voltage and half the time no voltage.
So SPI, Serial Peripheral Interface Bus, is also a thing that the RoboRIO supports, but most teams, including us, do not use it. But basically, it's like a master-slave control where the RoboRIO is the slave selector or chip select, and it selects a device to communicate with, and it'll communicate with that device one at a time. So there's several different ways to wire up an SPI setup. You can either have the devices in parallel or daisy chained together, one after the other. So relay is another thing on the RoboRIO. The relay pins are at the bottom, and you can use this for controlling the motor controllers, such as the spike bridge relay. And a relay is basically a way to control a high power device with a small power signaling device, such as the RoboRIO. But you would only be able to control your motor full speed forward or full speed reverse.
So sometimes you want to have more ports than you actually have on your RoboRIO. And this is when you can use an expansion board. The MXP is the port on the RoboRIO in the center lower part of it, where you can plug in other boards to extend your ports. There are many pre-made boards out there, but you can also make custom boards. Custom boards have to only extend signal pins and not contain any active devices. So some active devices, some active boards that are already approved by FIRST are listed right here, and they can do things like data logging, driver control and status, field orientation, and can provide additional GPIO and analog input.
And 1678 used to use the Spartan expansion board. It was a nice board for expanding the pins, and it gave us an extra encoder pin that we used for our encoders before we started using mag encoders. And another thing on the RoboRIO, the power port is in the top left corner. The RoboRIO has a USB device port where you can connect your computer to the RoboRIO. Has Ethernet, which is where the robot radio would connect to the RoboRIO. Has a USB host ports where you can power and use some devices such as a USB camera. The RSL port is down at the bottom where you put your robot signal light on. So that's our presentations. If you have questions or feedback, you can scan that code. You can also email anything to that email. Thank you. Are there any questions?
I'll start with that. So when you buy a common SRX, it's got about 6 feet of CAN wire on it.
Yeah.
So if you're connecting it to the telephone right next to you, you got 6 feet of wire and then a connector and then another 6 feet. What's your guys' standard? How short do you cut it? And which connectors do you put on the end to get a thing connected?
So you usually want to try to do it as short as possible, like the minimum length to connect to the next device. And when it's shorter, you'll also get a cleaner signal and more efficient data transfer.
Okay, so there's nothing about the CAN bus that requires at least some number of inches for the signal to get started and get up to speed and get to the other one. You can go as short as you can.
Yeah, I think you can go as short as you can. And then we use the PWM crimps, like the servo connectors where there's the male and female.
Okay.
So those are easy to connect and disconnect. They're the same crimps that you use on the PWM speed controller signal wire. Any other questions?
So you said at one point there were like something cages that block off like magnetic disturbances.
Oh, yeah.
I don't remember. Did you say there are specific ways to block off electrical disturbances too?
So Faraday cages, they're like metal enclosures. Some sensors on the very inside have metal things that'll prevent noise. But usually when you have a sensor and you think it's getting a lot of noise, the best thing to do would be to mount it in a different place away from noisy devices such as motors and the radio. Yeah.
You had mentioned that there's some first approved expansion boards. So does that mean that if you just make up your own, you need to get approval for it, or can you make up your own?
So you can make your own expansion boards as long as they're passive devices, so they don't alter the signal with external inputs. So if all you did was like expanded the ports to be easier to plug into, you can use your own. But then you have to use the list of, or one of the approved active devices from first, and they're listed in the game manual every year.
Make your own active board.
No, you can't. Are there any other questions? Yeah.
Go with students first.
The birds had a sensor into the CAN loop. Would I have to add a 120 resistor for every sensor, right? For every new sensor? Or?
So the terminating resistor is only at the very beginning and very end. Yeah.
Why did you guys
So we used to use Spartan board because we used to do a PWM wiring setup, and we need to route all our signal wires from the speed controllers to the RoboRIO. But then we switched to the CAN setup where we can just have all our speed controllers in the CAN loop and then use the canifier to put in sensors. And then we also use the pigeon for the gyroscope and accelerometer because that just easily connects into talons. Are there any other questions?
I guess I get to go now. I'm trying very hard to drive our team to think in terms of best practices or rules for doing things in a way that we know works. And just one small example that we picked up, and we might have gotten it from you guys or somebody taught us, when the RoboRIO is on your robot, put a piece of tape across all the open ports so nothing falls in and shorts out any of the things.
Yeah.
It's a very simple thing that's on our list of best practices. What are some of yours? So if you get a freshman who joins the electronics team, what are the first 5 things you teach them?
Well, I guess one thing, so always label your wires, the beginning and end, because when you get a complicated robot like the one in the past season with the elevator that goes up and down, and then a sensor breaks or something, it'll be really hard to trace the wire. So labeling is really important. You also want a good strain relief. So like on a sensor, you don't want a really sharp angle coming right out of it. And then when you solder motor leads to like 775 Pros, we always zip tie the leads to the base of the motor. So if something pulls on the wire, it doesn't pull on the fragile leads, it'll pull on the whole base. It's also wiring. We try to do nice 90-degree angles, not like 45-degree angles where everything gets crisscrossed. It's easier to trace wires and makes your robot look nicer. I guess those are a few. Yeah.
Talon XRXs, I saw that you're able to make your own connections for the, like the diagram. Is that just like on a user manual? Because I saw a do not connect, and I just want to make sure I don't like short out my Talon XRX.
Oh yeah, so you can, there's lots of, or there's two, or there's a few expansion boards that they sell for the Talon SRX, where you just plug it into the Talon and then it'll spread them out so you can easily solder onto them.
Wait, sorry, can I just ask that? Is that like online?
Yeah, you can just type in Talon SRX data port expansion board. Yeah.
You were talking about the best practices. Do you try to emphasize which color you use for which type of signals, or in general?
The usually signal wires, we used the PWM cable, like the red, black, and white. That looks like that wire. We usually use those for our sensors. Red is always power, black is always ground, and then white's always signal. When we used to use the optical shaft encoders that had the 5 pins with lots of different signal wires, we would always have the same ones go to the same places. We write that down, so it's always the same. Any other questions? Okay, guess we're done. You can look at the email or the QR code if you want. Oh yeah.
So what's the name of your QR code again?
I think you can ask questions or give us feedback. Thanks for coming, everybody.